Let's talk about order of operations. If you look at our expression here, and remember, a numerical expression is just a collection of operations and numbers. That's why we call it numerical. And we want to evaluate this. So we have 3 plus 4 times 2. Is it 11 or is it 14? You can do it yourself and see. Well, let's take a look at this. If I add 3, let's do it over here. If I add 3 plus 4, I get 7. And I know that 7 times 2 is 14, so it looks like 14 is correct. But some of you might do this. Some of you might say, no, that doesn't look right, because I know that 4 times 2 is 8, and I know that 3 plus 8 is 11. Shouldn't they both be correct? Well, let's think about what would happen if they were both correct. If we were engineers and we were doing measurements according to a blueprint, what would happen if you interpreted it as 11 and I interpreted it as 14? Even though they're both mathematically correct, that bridge would fall into the river because our measurements need to be exactly the same. And so mathematicians a long, long time ago, even before I was born, set out to make a convention or a set of rules where everyone would do their operations in the same order. And we call it order of operations, and there are different ways different teachers will tell you, oh, this is how you remember it, and they're called acronyms. And here we aren't using the one that I don't even like to talk about, that we used to use when I first started teaching. Today we're going to use GEMA, which I did not make up. I stole it from another teacher who said that it was great, and I've been using it ever since. And this is the way it works. So we are going to first start with groupings. And what we're going to include in groupings is parentheses, right? We always know about that, parentheses. And brackets. So parentheses look like this. Brackets are not just for basketball. Brackets look like this. And then we have fraction bars. That's something different, okay? That's something you don't usually talk about. And that is just if you had 3 times 2 over 2, okay? So that would be, we would do the numerator first and then the denominator. Exponents, we know what exponents look like if I see this. Okay, so first I'm going to go to the left. I'm going to go all the way across. I'm going to look to see if there are any groupings that I can figure out, right? I want to do the operations inside the groupings. And then when they're all done, I can go through it 5 times. If there are 5 groupings, I start at the beginning each time. For exponents, I do each exponent, go back to the beginning. Did I clear all my exponents? Yes? Then I move on. The next thing we do is multiplication or division. And the reason that these are grouped together is because they're inverse operations. And we learned when we divided fractions that every division problem can be rewritten as a multiplication problem using the reciprocal, okay? So those have the same, what we call the same power, okay? And I don't mean that in an exponent way. They're the same strength. And we're kind of doing this decreasing in strength, not really importance, but you know, the change that it has on numbers. So after we think of multiplication as stronger than addition, right? Because it grows a number faster. So after we finish going through our expression over and over again until we get rid of all the multiplication and all the division, we're going to go to addition or subtraction. And that's the last thing we clear out. Now, it is important to note that multiplication and division have the same importance. So if I see division before I see multiplication as I go from left to right, that's what I do first. And we'll see that in a minute. So the last thing we do is we get rid of all our addition and subtraction. And what we're going to do is we're going to do one or two of these, and you're going to see that we like to do everything one step at a time and then go back to the beginning and check. I like to circle the operations that I complete. So let's see, I want to look at this expression and I want to look for groupings. Okay, what do I see? I see one set of parentheses. Okay, I'm going to rewrite everything else. 1 plus 3 is 4, and that gets rid of the parentheses. So 4 squared, I can't forget that, divided by 2. Are there any other groupings? No. So I'm going to check that off. Okay, next is exponents. I start from the left, I look, oh, there's an exponent. I'm going to rewrite everything else. 4 squared, 4 times 4. If you have to, do this on the side. Expand it. 4 squared is 16 divided by 2. Any other exponents? No, so I'm going to check that off. Now, I'm looking for multiplication or division. Whatever I see first from left to right, I do first. So I have 5 plus 6. No, that's addition. Oh, here's division. Okay, 5 plus, what is 16 divided by 2? That would be 8. Any more division or multiplication? No. So I check that off. Addition or subtraction? Well, here we go. 5 plus 8, 13. And that is my answer. And I am finished. So that's the basic way that we tackle these things. Now, let's see if I have something like this. Let's say I have 12 divided by 6 times 1 plus 2 minus 2 plus 5. Okay, what am I going to do about this? Well, I'm going to write GEMA, and I'm going to go through my steps. Are there any groupings? Yes, there are. Rewrite everything else. 12 divided by 6 times 3 minus 2 plus 5. Okay, any more groupings? No. You can check it or you can cross it off. Exponents, any exponents? Go through the whole thing? No. Any multiplication or division? Now, do you see I have multiplication and division, but I go from left to right. The first thing I see is the division. It has equal importance with multiplication, so if I see it first, I do it first. 12 divided by 6 would be 2. Rewrite everything else. Okay, can I check off the M? No, because I still have some multiplication left to do. 2 times 3 is 6, minus 2, plus 5. Any more? No. Okay, now I'm going to look for addition or subtraction from left to right. The first thing I see is subtraction, so I'm going to do that first. 6 minus 2 is 4, plus 5. Am I done yet? No, I have to add. 4 plus 5 is 9. Nothing left, so I am done. Now, I want to caution you because students, since I've been teaching, think that you do multiplication before division, you do addition before you do subtraction. That is not the case. What you see first from left to right, you do first.